Hello everyone, this is Rajat from IIT Bombay, and today we will discuss question 50 of GATE 2020. We have to find the percentage error in the ground state energy of a particle in 1D box of length A, described by a trial function of x into a minus x. The given ground state energy is h square by 8m square, and the psi star psi d tau is a to the power 5 30 in between 0 to a. Now, this is a problem that can be solved using the variation principle. So we have to first understand what is variation principle and how we can find the energy using the trial function that is given. Now, in basic quantum mechanics, the problem starts with a system with one electron. Let's say what we generally say as H-like atom. And if we find the solution from Schrodinger equation of that H-like atom, the true wave function, let's say, be psi naught, then we can find the value of any parameter if we know the exact operator for the that parameter itself using the formula this, where a is the parameter value that we are looking for, and a hat is the operator for that parameter. Psi star, psi naught is the true wave function that we are talking about, the solution from Schrodinger equation, and psi naught star is the conjugate part of that wave function. Now, this is a scenario for a one electron system, but as we know, there are systems where we generally want to use this kind of theory, the multi-electron systems. This wave function that has been generated will not gonna work. So for that, we have to do some approximation and modify this psi so that we can use that psi for those many electron systems. And for that approximation, there are different methods to do so. One of them is using variation principle or variation method, where we generally do take some trial functions, let's say psi, different ways, and then we generally try to find some parameters. For example, that the question that we are talking about, we, let's say, go with the scenario itself. We consider the energy, we calculate the energy for that trial wave function, and then compare that energy with the ground state energy of the psi naught that is there previously. And then from that comparison, we can comment how our trial wave function is better compared to other trial wave functions that are there. Now, to go with that and to find the energy, we use this previous formula that is there, and the operator for the energy itself is nothing but the Hamiltonian operator, that is represented by minus h cut square by 2m del 2 del x2 plus Vx. So Vx is the potential energy, and this is known as the kinetic energy operator. Now, after using this operator and finding out the value from this integration, this integration has its own limit depending on which kind of uh, system we are talking about, and from that we get the value of B. Now, if we know by somehow from the original solution of Schrodinger equation the E naught for that specific system, or we can calculate that in a different approximations using different approximations, the percentage error, you can calculate the percentage error for that specific system itself via using this basic formula. So to understand or calculate the percentage error that is there in our question, we need to find the E for the system. Let's get back to the question itself. What are the given things that is there in the question itself? Is nothing but, first is the particle in the system is itself particle in 1D box. Now, as there is no information for the Vx potential for that particle, we'll consider, if there is a formula, we will use that formula. If it's not there, we'll consider that the particle move parallel to the x-axis with a zero potential energy in this situation, and that's why we consider Vx equals to 0. So the energy operator now becomes only the kinetic energy operator. A trial function that is given is x into a minus x. The boundary that is given is 0 to a for this system. As you know, this that is the definition of boundary for particle in 1D box. The ground state energy level is also given, that is h square by 8 m square. So using these all the things and the psi, we can calculate the first we calculate the energy and then we compare the energy with this value. For that, let's go with the formula that is there. So we substitute the psi value here. Psi star, as psi has no imaginary counterpart, so psi star and psi will be equal. So that's why that is given written in both position of psi star and psi. H operator is now written as minus H only the with the kinetic energy operator. There's no Vx, and go with that. Psi star psi d tau that is there, that is given for this equation is nothing but 8 to the power 5 by 30. So this value can be replaced by 8 to the power 5 by 30. This minus h square by 2m can also be taken out, so it will look something like this. Now this part is nothing but a differentiation. We know the differentiation formula for ddx of x to the power n is nothing but nx to the power n minus 1. So if there's a double differentiation, the first differentiation will produce x becomes ddx of x become 1, so a into 1 is 1 a, then minus s square x differentiation of x square is nothing but 2x, so minus 2x. Then the second differentiation make this a 0 because it's a constant, and minus 2x will produce minus 2. So this minus 2 can be taken out. So the final form of this part becomes 30 h square by ma to the power 5, and the remaining part, so it looks something like this: 30 h square by ma to the power 5, 0 to a, x into a minus x dx. And then we have to do the integration. So the final form ax minus x square converted to the 0 integration of x dx. Again, a is constant, it will be taken out of the integration, and minus up 0 to a x square dx. Now for our integration part, we know integration of x to the power n dx is nothing but x to the power n plus 1 by n plus 1. So, and the limits that are there will be there on the final result also. So that has been written here. Integration of x dx will be x to the power 1 plus 1, that is x square by 1 plus 1, so 2. So it becomes x square by 2. Similarly, integration of x square will become x to the power 2 plus 1, so x cube divided by 2 plus 1, that is 3. Now we can use those limits to find the actual values. That is nothing but substitute those values to the system. So x to the power n with the limit of d and c becomes d to the power n minus c to the power n. So that will be there, a square by 2 minus 0 square by 2. This part becomes 0. Again minus of then this part, a cube by 3 minus 0 cube by 3. This part becomes 0. So this part ultimately becomes a into a cube by 2 minus a cube by 3. And if we continue with those with some specific algebras and then crossing out what are the 6 and 30 and so on, the final value we get is 5a square by 4 pi m square. Now we have the value of the ground state energy function that is there for a true wave function, that is h square by 8 m square. So we know E, we know E naught. We can now calculate the percentage error using the formulas, substituting the values that we have there. Can then take common out h square by m square in the denominator and numerator. The final form will be something like this. We can substitute the value of pi, that is 12 by 7 or 3.14, and get something like this, and the final result that comes out is 1.28. Now the reported result for this question itself is the range of 1.22 to 1.44. So our result that comes is in between the reported result range. So I hope you people find this solution helpful. If you want to know more about the variation methods and variation principles, and it's you can follow this YouTube link to go through the course lectures of quantum chemistry of atoms and molecules by Professor Anindya Datta, Department of Chemistry, IIT Bombay. That's all from my side. Thank you.